what we're going to start with as our first example is just understanding sort of what algebra is and why it's useful to us in a mathematical context. So we know that as we've started with algebra, what we've sort of started working with is algebraic expressions, simplifying algebraic expressions, and hopefully starting to understand why they're useful to us. So we're just going to start very basically by setting up some expressions for ourselves so that we can mathematically put a problem, no, I need to say those words the other way around, so that we can take words and put it into a mathematical sentence. All right. So here we've got an example that Catherine has Y shirts. So we don't know how many shirts she has, but she's got shirts, Y number of shirts. Linda has 3 times as many shirts as Catherine, and then Linda buys another 7. So we've got a situation going on here. We've got 2 people, Linda and Catherine. Linda has some shirts, Catherine has another shirts, and then Linda's decided she's going to go buy some more. Now we have to be able to take that scenario and write it in mathematical language, so write it as an expression. So the first question asks us to determine an algebraic expression for the number of shirts that Linda has after buying the 7 extra shirts. We got there in the end. So if we just start with these first 2 sentences and break this down in terms of our 2 people. So we've got Catherine and we've got Linda. Right now, Catherine has Y shirts, and it tells us that Linda has 3 times as many shirts. So on the chat for me, guys, how would you express 3 times as many shirts for Linda? How would we write that as an algebraic expression? So how can I take what I know about Catherine's shirts and translate that to what we now know about Linda's number of shirts? They keep them coming. Good, grade 8s. Okay, so like Andile's put there on the chat, which is quite nice, is it helps to know what 3 times as many means. 3 times as many means that I'm multiplying my value by 3. So if I need to multiply our value by 3, we know that it is 3 times y. And because we've now done, your guys English, and because we've now done algebra quite a bit, we know that 3 times y simplifies to 3y. So we know that before Linda buys any shirts, she's got 3y number of shirts. So on the chat for me, guys, what would my expression now look like if we now take into account the number of, or the 7 extra shirts that she bought? So what would Linda's expression look like with the 7 shirts that she bought now accounted for? What would that look like? So we know she starts off with 3y. What is she going to have after she's bought the 7? Okay, we got some different answers going on. Let's see, keep them coming. Tingle, I'm hoping that equals was meant to be a plus. Good, grade 8s. So we know that Linda starts off with 3y shirts. She buys an extra 7. And so if we're adding 7 to what she already has, our expression needs to be 3y plus 7. Now, what we need to understand is that this expression, if we look at it, yes, it's 3y plus 7, but it is actually telling me in mathematical words this whole scenario that we wrote out as a sentence. So that 3y plus 7 is putting into maths language what the English was saying. And we need to be able to take word sums, this is why we do word sums, and put it into mathematical language so that we can start solving problems or solving for X or Y or whatever the case is as we move on, especially in problem solving sorts of questions. All right, so now the question B says, if Catherine has 10 shirts, how many more shirts does Linda have than Catherine. Okay, so if we go back to our original statement, we were told that Catherine has Y shirts. So what that means is they are telling us that Y is equal to 10. So we have an expression for Linda in terms of how many shirts she has, 3Y plus 7. And so what we now want to do is we want to take what we know Y is equal to, and we want to figure out how many shirts Linda has. So quickly again on the chat, can someone tell me how many shirts Linda has altogether if we now know that Catherine has 10? Lakani, I'm not too sure why your hand is up. I'm assuming there's a problem. Remember, we only raise our hands when I say so. Is something wrong? I think we might be having an audio issue there. Alrighty, guys, good. So I'm glad our maths is working tonight. We know that Y is equal to 10, so we've got 3 times 10. Please remember that this number in front of your variable is the coefficient. The operation between your coefficient and your variable, so the number and the variable, is multiplication. So it's 3 times 10 plus the 7 that she went and bought. Now, hopefully we know that 3 times 10 is 30, and 30 plus 7 is 37. So Linda has 37 shirts once she's bought the extra 7. If we wanted to know how many shirts she had before she bought the 7, we could just work with the original expression that we had of 3Y. But once we have that mathematical sentence that explains the problem in maths, we can go and work out a whole bunch of different things. Right, now this sort of English. It's clear I haven't been teaching for a while and it's been exams because I haven't been using my words often. This goes back to what I was saying about the Maths 24. We need to be able to use our numbers when we are given them. This is a very basic operation that we need to be able to do, and we need to make sure we do it properly. Now, grade 8s, remember, sometimes we will say without a calculator, but use your calculator to check your answer. If you've done some sort of working out and you're not 100% sure, just pop it into your calculator and double check. If you're getting 2 different answers, you need to go back and check your working out. And it's really silly to lose marks for a silly reason. Alrighty, so this is how we take words and we put it into expressions. And like I say, guys, when we start doing problem solving, so once we start doing algebraic equations and we start looking at sort of word problems, being able to write an expression is going to be very helpful to us. Right, I'm going to stop there, take your screenshots. If anyone has any questions, you can raise your hands. Otherwise, we'll have a look at another example. Okay, so now's the time to raise your hands for questions if you have any. And remember, guys, always put your questions on the chat. Lakani? Oh, no. Okay, I didn't do anything. BK, tell me.
Hi, ma'am.
Hi.
It's been a long time.
It has, yeah.
Yo, ma'am, so, for example, ma'am, if you have multiple numbers, ma'am, like, for example, Lina has 10 and Karin has 17, right? What would be the number of Jason's I'm just making a name, ma'am, of Jason's pair, ma'am.
Okay. Okay. Hang on a second. Right, BK, try again because my internet was a bit dodgy. Maybe turning my camera off will help. Okay.
Okay.
Let's try again.
Linda.
So are you basically asking me if there were 3 people, what would happen?
Yes, ma'am.
Okay, cool. So, I mean, 3 people I don't want to say it doesn't change anything because it doesn't really. But it does mean that we might have to do more expressions. So what we could do is, let's do this. So let's say we had BK has X chocolates, I don't know, sweets.
Yay.
So it is you, yeah. Swallow has 7 more sweets than BK. BK, and then Kelsey has twice as many sweets, as Swallow. Right, so I could add as many people or as many things as I wanted to, but then I could ask you for an expression for all of the people, all of the situations that I'm talking about. So here we've got 3 people. We've got you, Swallow, and we've got Kelsey. And then you just break it down for yourself. So you've got X sweets. If we now move on to our next information, Swallow has 7 more sweets than you. So this would be X plus 7. Kelsey has twice as many as Swallow. So we know how many Swallow has. She's got twice as many. So we would times that by 2. Do you agree with that?
Okay. Okay. Yeah.
Okay, so twice as many means I need to take whatever the expression is and I need to times it by 2. So if she's got twice as many as Swallow, we would times that by 2. And then we can start to ask you questions. So then I could say, okay, if BK had 10 sweets, how many does Kelsey have, or how many does Swallow have? If they've got, I don't know, 30 sweets altogether, how many sweets do they each have? And so now we can start building on. But this is why I'm saying if we can do the expressions, hopefully everything else becomes easier.
Oh, okay. Interesting. Yeah. As usual.
Right, so guys, this, I mean, I should have just done this example because this is a much nicer one. But this is why being able to write expressions is important, because now that I've got this base words, these are okay, we're going to try again. Now that I've got these 3 expressions that form the basis of my question, I can do whatever I want with it. I can now tell you how many sweets BK has, and ask you to work out the others. I could tell you that altogether they've got whatever, 100 sweets. How many do they each have? And because you've got these expressions, you can now work with that. All right, so it doesn't matter how many people we're working with, whether it's 2, 3, 17, we won't give you 17 because that's mean, but we can always, or we will always need to be able to relate it back to whatever our original was. And we will give you that information. I'm not just going to say BK has sweets and Swallow has sweets. I'm going to give you something about it. Swallow has 7 more. Kelsey has 2 times as many as Swallow, whatever the case is, so that you can go and write the expressions. Right, I'm assuming no more questions. I'm assuming you've got your screenshots here. I know I moved away from it, so I'm just going to wait for 10 seconds. Righto. Now, in addition to these expressions, and like I say, this is going to become a lot more useful to us when we start doing equations, we also need to know our basic terminology when working with algebraic expressions. Now, we've done these many, many times, and so I really hope we all remember these definitions, but we're going to go through them again just in case. So here I'm giving you an expression, and like I've said to you before, this is how we often like to test, do you know your terminology? So do you know the meaning of certain definition or certain words? So here I've given you an expression, 2x plus 10 times y plus 2 plus y plus 3 over 3 plus 1. So there's a fair amount going on, and this is what we like to do. We like to give you an expression that's got a lot going on, because now we want to test, do you know what terms are? Do you know what a coefficient is? Do you know what a constant term is? Are you able to substitute into an expression, etc., etc.? Alrighty, so first question is, how many terms are there in this expression? So would someone like to raise their hand and tell us what a term is? How do I identify terms? Dal?
Ma'am, so like, can you hear me?
Yeah?
Okay,
I don't know,
okay,
your
okay.
hand disappeared, but you're there.
No, I just took it away.
Okay.
So like, 2x is one term, and then 10 and the bracket y plus 2, that's one term also. That's like what? Two terms.
Mm-hmm.
And then the fraction is the third term, and the one is a fourth term.
Good. Now, how did you know those were separate terms? What did you look out for?
The symbol like separates them kinda.
Good. Good. Okay. So, guys, remember our plus and minus signs that are not in fractions or brackets separate terms for us. So, I'm going to ignore any plus or minus sign that is in a fraction or in a bracket. So, we've got this plus, this plus, this plus. Those separate my terms, as we've been told. And so exactly as Dal said here, we have got 4 terms. Those 3 plus signs separate term 1, term 2, term 3, and term 4. So once we know that, we now know we've got 4 terms in this expression, right? And I've told you, I've harped on about this lots and lots and lots, but being able to identify your terms, very, very important, because if you want to now simplify expressions, you need to know what terms you're working with. Alrighty, hands up. Who would like to tell me what a coefficient is? And I've sort of already told you a little bit earlier when we did our writing expressions. So what is a coefficient? Lakani? Oh, golly, I'm just unmuting people. I don't even know anymore. Okay, your hand disappeared. So Sinyane?
Hello.
Hello. What is a coefficient?
A coefficient is the number in front of a variable.
Good. And what is the operation between the coefficient and the variable?
Times, multiply.
Good, good, excellent. Right, so guys, that's exactly what a coefficient is. It's the number that is being multiplied with our variable. All right, so if I specifically asked you for the coefficient of x, the first thing we want to do is find x in our expression. We've only got one term with an x, which is term number 1. And so now we want to see what number is being multiplied with this x. We can see it's the 2. And remember, like Sinyane said, it's the number in front of the variable. So our coefficient here is positive 2. That is what we're timesing our x value or our x variable by. Right, Nelson, your hand's up, so I'm going to pick on you. Can you tell us what a constant is?
Hello, ma'am.
Hello.
A constant is a number that stands alone and has no variable.
Excellent. So guys,
What's
very
a term?
important. Sorry?
A constant term, ma'am.
Good. And which is our constant term here?
It's 1.
Good. Excellent. So guys, remember, and I've just said this, it's so important that we can identify our terms. We've got 4 terms here. We know that. The question is, which is the constant term? So if I look at my 4 terms, which one has no variable? Which one remains constant? And that is the number 1 there. So our constant term is positive 1. If that had been a negative sign, please remember that your constant would then be negative 1. So please always remember that the sign needs to go with its term. But in this case, it's plus 1. So our constant term is 1. Right. So again, this is how we like to test you on, do you know your terminology? In these questions, we also like to be able to test, do you know how to substitute? So remember, substituting, very much like what we did over here with our expression of, now we know that Catherine had 10 shirts. Now I'm telling you that x is equal to 1 and y is equal to 3. So in our expression, which I'm just going to rewrite for us down here, every single time I see an x, I'm going to have to substitute the value for x that I've been given And every time I see a y, I'm going to have to substitute my value for y. Guys, let's just remember to mute ourselves once our hand has been raised and any question or statement given, otherwise it's chaos. So over here, I have told you that x is 1. So every single time I see an x, I'm going to replace that with a 1. I've only got one x, as we've already established. I've also told you that y is equal to 3. So every time I see a y in my expression, I'm going to substitute in 3. So that's what I now need to go and do. I've got 2 times 1 plus 10 times 3 plus 2 plus 3 plus 3 over 3. There's lots of 3's going on here, plus 1. Often what we will do, grade 8, is we will very specifically say to you without a calculator. So you are going to have to show all of your working out in order to get your answer when you are substituting. So I'm going to give you 30 seconds on the chat. I want to see what answer you get when you substitute in those values for x and y. So take a second, show your working out. Remember on your piece of paper that you're doing these examples, show all of your working out so you can mark it. But I want to know what your final answer is here. Right, so I'm waiting for answers on the chat. And remember, grade 8, if you want to double check, you just type it into your calculator exactly as I've written down, and you make sure that the answer your calculator gives you is the same answer that you yourself have gotten. If you don't, you've probably done something wrong, or you've typed it into your calculator wrong. I can tell you now it's not 2. I hope we're not just jumping on the bandwagon here, grade 8s. You know how I feel about that. Okay. We're getting there, I suppose. Getting there. Okay. I'm going to write out the working out. And remember, you will have to show your working out because I've said no calculator. So guys, remember, we know which terms we have. Our terms are term 1, term 2, term 3, term 4. We're going to simplify each of those so that we know exactly what we're working with. 2 times 1 is 2. In our bracket, we've got 3 plus 2, which is 5. And we know that we're timesing that by 10. 10 times 5 is 50. Our fraction, 3 plus 3 is 6. And 6 divided by 3 is 2 plus 1. So now we just add everything together. 2 plus 50 is 52. 52 plus 2 is 54. 54 plus 1 is 55. I didn't see many 55s coming on there, so I'm not worried, but it's all right. Mark your answer. Make sure you agree with what's going on here. Please remember, because I made this mistake when I did it in my head, 3 plus 3, so in term number 3, we look here, 3 plus 3 is 6, and 6 divided by 3 is 2. It's not 3. So just be careful when you are doing your working out. Don't try and rush it in your head, and make sure that you are getting the correct answer. The next thing that I just want to say, I'm sorry, I forgot my normal calculator. So now we're using a calculator app, but that doesn't matter. when you type this into your calculator to double check, please remember to type it in with all of those brackets included. If you don't put in those brackets, your calculator sometimes does some odd things. So we just need to make sure that we are actually typing in our terms exactly as they need to be in order to get our answers. So if you have a look here, I've typed it in exactly as I wrote it down with all of the brackets, and I've double checked that is the answer that I get. All right, so use your calculator to check, because now that I can see that my answers match, I know I've probably got full marks for this question. If my answers don't match, I need to go back and double check. All righty. Take your screenshots. Any questions that you have, you can raise your hand now. Otherwise, we're going to start with a fun, no shame. I'm going to give you a brain break today, guys. I've been quite mean with brain breaks, and you are fully deserving of a brain break. So I shall do that today. But Nelson, but take your screenshots. BK, question. BK is getting them all out. He hasn't asked questions for ages. Now he's ready.
Ma'am, yo.
Yes. What up?
Okay, ma'am. My mistake was I rushed it. I thought that we must plus the 10 with everything, ma'am. Yo.
So your second option, and this
yes,
is
ma'am.
if you wanted to, you would have 2 times 1 plus 10 times the 3 plus 2, and then plus that 6 over 3 plus 1. The only other way you could deal with the second term is to distribute. So you would have 2 plus 30 plus 20 plus 2 plus 1. But that 30 and that 20 still gives you the 50. So just be careful. The operation between 10 and the bracket is a times.
Oh, interesting, ma'am. Very interesting. Yo.
Okay, so guys, that's also a good point BK sort of brought up. You don't have to simplify that bracket. And I have said that to you before. If you don't see that those are like terms, it's not the end of the world. You just distribute. You will get the right answer. But obviously adding together the 3 and the 2 does make our life a little bit easier. All right. Those of you asking about screenshots, it depends very much on the device that you are working with. If you've got a laptop, you can push print screen and then just copy that over to some sort of document. But honestly, I think the easiest thing would be to take your phone, take a photo of the screen. Then you've got it. Alrighty. So I hope we all have our screenshots. Although I'm saying that some of you are asking about screenshots, so I'll wait for 10 seconds. That is cold. Okay. Oh, look at that. Perfect timing. Brain break. I feel like I might have had this joke before, so I do apologize in advance if the joke has been had. But it's fine. Your brain break, guys. Remember, we know how to do this. We're going to wait for the first answer on the chat, and then we're going to pick on you. What we want is we want the value of this very last expression down here. So you're going to have to work through that, and you're going to have to figure out what each of the, I'm going to say that's a polar bear. So that's a polar bear, that's a koala, and that's a monkey. What each of those are, so that we can work out the value of the last expression. Better do that quickly as well. Okay, so I want answers on the chat. Whoever gets the answer correct first, I'm going to pick on you, and you're going to explain to us how you got there. I'm doing it with you. Let's go. Tatenda helping me out here, first step. I hate my times tables, guys. I'm not good at times tables. Right, I have an answer. Not seen it just yet. Let's see if Simone agrees with me because that was very quick. And we know sometimes my maths is a bit questionable in the evenings. Simone's gonna roll with me. I want to say my maths is okay tonight. I'm just gonna double check myself. And guys, remember, look out for where there's two pictures. I'm just gonna zoom this in a bit because in that last one you are calculating, there's two polar bears and there's two monkeys. I know Yolanda always shouts at me when I tell you to look out for two. So we can just imagine her shouting at me right now. But just remember to look for the two pictures. Remember BODMAS as well, guys. Love when we don't agree. Oh, we're taking long tonight, grade 8. Clearly we haven't done a brain break in a while. Same time that I'm sort of feeling that, but you got it. You can do it. Okay, guys, 1 more minute. Mungu Musa, I'm going to be honest. I am agreeing with your answer, but we are going to problem solve this. So if you want to raise your hand and let us know how you got that, let's see. Hopefully we're right. So I think you were the first one who got it. Mungu, if you want to raise your hand, you can help explain it for us. If not, Nelson, do you want to explain it or do you want to raise your hand? Okay, Nelson, walk us through this.
So, ma'am, what I did first was that I said 24 divided by 3, which gave me 8.
Good.
Then I said the dog gray panda, like light green, is 9.
Good.
Since 8, which gave me 80.
Good.
Then I said I tried to figure out, since we plus 9, what makes 100. So I said 10 times 10 gave me 100 plus 9. Then I added the 9 by the greenish thing. Then I added board mass. I said since one panda gave me 8, 2 will give me 16.
Good.
And I said since 10, one monkey gave me 10, 2 will give me 20.
Good.
And I said 16 16 times 20, which gave me 320,
Excellent.
plus 9, which gave me 329.
Awesome, Nelson. Well done.
Thank
Okay,
you,
guys,
ma'am.
I hope you all heard Nelson say there, and I said we need to use BODMAS. So here in the second step, we have to do that multiplication first. 7 times 9 is 72. Hence 72 plus 8 is 80. Again, in the third step, we have to do BODMAS. So we have to do that multiplication first. And so remember to use your BODMAS. I can't tell you how many times I had to write BODMAS on exam papers that I marked this year, because BODMAS apparently doesn't exist for some. So please remember BODMAS, sweet children, please. Right. If you want to take a screenshot, you're more than welcome to, but remember this is just our brain break. I think we just haven't done a brain break for a while, so we've gotten out of the habit. That's completely on me. I get carried away sometimes. But well done on giving it a try, guys. Let us continue on with some algebra though. Righto. Okay. So this is really what we need to be able to do with algebra. This is the bulk of the sort of questions that we ask you. You need to be able to work with expressions and you need to be able to simplify them. Now, I have said this word and this phrase so many times that you should be dreaming about it at this point in your lives. Whenever we simplify an algebraic expression, we obviously need to do the correct order of work. So we need to follow BODMAS. Because like I say, BODMAS is unfortunately a thing you have to live with, whether you like it or not. And we need to look for like terms. Now remember, like terms are those that have the same variable and the same exponent. We're not going to stress too much about the exponents at this point. Once we've spoken about exponents again, we'll chat about it. But it is important to remember that like terms, same variable, same exponent. Now, I've said this to you guys, when you are simplifying expressions, if you are going to identify your like terms, get a colored pen, get a pencil, get a highlighter, whatever, and highlight your different groups of like terms. So in this first question, identify your like terms for yourself. You can see that there's no multiplication or division or brackets or anything that we need to deal with. So all we need to do here, according to our order of work, is add and subtract terms. So I want you guys to try this by yourselves. I want to see your answer in the chat. And I've already given you a hint. Find your like terms and add and subtract them. So I'm going to give you a second. Answers in the chat, and then we'll have a look in a minute. You can do it. I'm pretty sure you can all do it faster than a minute though. Remember your signs, just take careful note of your signs. Good, grade 8s. I'm going to give everyone another 10 seconds to make sure they all agree. Bakani? Not too sure what's happening there. I hope it was just a typo. All right, guys, good. So, like I say, identify your like terms. So we've got an x term, which is 2x. We also have a 3x. We have a minus 2x, and we have a minus x. We know those are all like terms because all of them have 1x in their whole value. Now, grade 8, remember, if it helps you, you are more than welcome to write a 1 coefficient in front of a variable that sits by itself. If that helps you to simplify, by all means do it. What we also see is that we've got another group of like terms, which are our constants. We've got the +7 and the +9. Now, I've said this to you before, you don't have to do this. If you are more comfortable writing all of your like terms next to each other, so sort of grouped together before you start to simplify, that is absolutely fine. You don't have to do it. I personally wouldn't do this myself, but if you want to, that's okay. So what we want to do now is we want to add our like terms. So 2x plus 3x is 5x, minus 2x takes us to 3x, minus another x takes us to 2x. Please, excuse me. Oh, okay. Please remember that when you add and subtract your like terms, those exponents, thank you, Simone, those exponents do not change. Exponents only change when you multiply or divide. When we add or subtract, exponents don't change. I'm going to write that note down for you just now. Then we have to add our constants, 7 plus 9. So 7 plus 9 takes us to positive 16. We always double check if we've got any more like terms. I don't, because I've got a constant and I've got a term with an x, so they're not like terms. And so this is my final answer. So guys, very importantly, double check for like terms. And remember that when we add or subtract like terms, okay, my words got away from me. Frankly, again, like terms, the exponent doesn't change, or the exponents don't change. All right, so please bear that in mind. We don't want to make a silly mistake by saying something like 2 to the power, or rather 2x to the power 4 or something. It's just 2x. You've started with 2x's, you've added another 3. It's like adding oranges to oranges. If you add 2 more oranges, you just have an extra 2 oranges. It doesn't become oranges squared. Alrighty, so if we now have a look at something like the second one, this is now where order of work becomes important. So I said to you right at the start, order of work in like terms is really important. And this is now where we now need to identify terms for ourselves so that we know which terms need simplifying. So I think it was Dahl, if I remember correctly, we said that in order to identify terms, we look for plus and minus signs. So here's a plus sign, there's a minus sign, and that's the only plus and minus signs I have in this expression. Those are separating my terms for me. So this whole 2 times x times 3 is my first term. 4 times x is my second term. 3 times 2 times y is my third term. Once we know where our terms are, so once we have identified our terms, we can now go and simplify each of those terms. We need to do that because we don't really want to work with all of those multiplication signs. If we can do the multiplication and simplify, it makes our life easier. So what we want to do is we want to now go and simplify each term. Now, this is going to be more important when we get to term 3, but please remember that when you are multiplying, you need to take note of the signs. So in term 1, everything is positive there, so I don't need to stress too much. If you want to, work with your SNV, signs, numbers, variables, or you can just multiply, completely up to you, what you're comfortable with. Everything's positive there, so in terms of the S, I know I'm working with a positive. Number, 2 times 3 is 6, and then I've just got my variable x. Simplify the whole of the first term. When I get to my second term, I've got 4 times x, positive times positive is a positive. Remember, there is a coefficient of 1 there, so 4 times 1 is 4, and then I've got my x. And then in my third term, now we need to be careful, we've got a negative here. So in terms of signs, I've got a negative times a positive times a positive. Negative times a positive is a negative. Negative times a positive is a negative. So I've got a negative here. 3 times 2 is 6, and then I have my y. Now that I've simplified all of my terms, remember we always want to double check if I have any like terms in my expression before I just finish off. I can see that I do because I've got 2 terms with an x in them and 1 term with a y. So this is now going to simplify to 10x because 6x plus 4x is 10x minus 6y. So guys, if we can follow those 3 steps that I've written down there, we can simplify any expression. remember what's useful sometimes, especially if you do struggle with your order of operations and simplifying your terms, is FMV, signs, numbers, variables. If you can follow that, you should hopefully get most marks or all of the marks for your question. We need to just be very careful in identifying our terms so that we can simplify. And this is why we identify the terms, grade 8. We don't want to rush. If you had just tried to do all of that in one go, you're going to make a silly mistake. It just is. There's a lot going on there. We don't want to try to deal with everything at once. So break it down, do each term individually, and then get your final answer. Alrighty, so grade 8, take your screenshots. If anyone has any questions, now is the time to raise your hand. Excuse me. Nice. Okay, CM Tanda. Oh, no, I muted you. I'm so sorry. I tried to click unmute again. Okay, let's try again. There we go.
Hi, ma'am.
Hi.
Sorry, my laptop just went off. For A, I got 3x plus 16. Don't know where I went wrong.
Okay, so the only place I could maybe see something having gone a bit funny is with this last term. So remember, 2x plus 3x is 5x. So 5x. Then we've got 5x
Oh,
minus.
right. Okay.
Figured it out.
Okay, now I remember. That I have to put a number in front of the variable. Okay.
Yes.
There's a 1. Okay, now I remember. Sorry, ma'am.
Good, well done.
Yes, ma'am.
So guys, that is a very important lesson in when you write things down, exactly like CM Tanda's done. You can then see very easily once we start going through it where you might have gone wrong. All right, Nokutenda?
Okay, hello ma'am, can you hear me?
I can.
Okay, so I wanted to ask, you say that there is an invisible one in front of the variable. So our first term we have 2 times x. So I wanted to ask, we don't multiply it.
Okay. Nokutenda, try that again. Sorry, you seem to lag a little bit. Let me see if turning my camera off helps. Try that again for me.
Okay, so you see the first term and the third term, there is the variable x and the variable y. So you say that there's always an invisible one in front of it, but I see that we only did 2 times 3. We didn't say 2 times 1 times 3. Oh,
so you can. Okay, so that's also a really important point. You definitely can put those ones in front of the x and the y, but remember, timesing by 1 doesn't make a difference.
Yeah, it stays the same. Okay,
exactly. It's more important in the first question where we were adding or subtracting. Well done.
Okay,
Righto.
thank you.
Good. BK?
Yay, ma'am. Sure. How would you know? I know you have to use your cards and everything, ma'am, but if there's a lot of multipliers like this, ma'am, like B, ma'am, how would you also know how many terms are they, ma'am? How would you know the terms?
Okay, so remember, terms are separated by plus and minus signs. So we would ignore the multiplication signs and the division signs, and we would identify the plus and minus. So in pink there, I've highlighted the plus sign and the minus sign. That's separating my terms. So everything before the plus sign is a term. Everything between the plus and the minus is a term. And then everything after the minus is a term. So once you know where your plus and minus signs are, you can separate your terms and work with each term.
Okay, ma'am.
Okay, good.
Interesting, ma'am.
Of course it is. Alrighty, guys. So I'm hoping that everyone is understanding, and thank you, Simone, for explaining for everyone there in the chat. I hope we've all got that.